Now let us proceed with the trigonometric identities. We know that the six circular functions are the sine, cosine, tangent, cotangent, secant, and cosecant. Now let us have a review of trigonometric identities that we need to know. As we can see, here's the magic hexagon, which is a figure that we utilize to determine various identities in an instant. How do we use the magic hexagon? First, co-function identity. Select one of the functions, and the function that is horizontally adjacent to it is its co-function. For instance, we have tangent, and the horizontally adjacent to it is cotangent, as we can see in the hexagon. The same is with sine and cosine, secant and cosecant. If a function is the cofunction of another function in trigonometry, then theta, the theta of that function is equal to 90 degrees minus theta of its cofunction. For instance, tangent theta is equal to cotangent 90 minus theta. Cotangent theta is equal to tangent 90 minus theta. We have sine and cosine and secant cosecant for the other two. Next up, Pythagorean identity. Consider the triangles shaded in gray. When you square the two functions in the triangle's base and added them, the sum is the square of the function in the vertex. For example, let's have this triangle. Tangent theta, 1, and secant. Tangent squared theta plus 1 is equal to secant squared theta. You can also form a same relationship with sine, cosine, and 1. Sine squared theta plus cosine squared theta is equal to 1. And lastly, 1 plus cotangent squared theta is equal to cosecant squared theta. The reciprocal identity, we select a function and look at the function diagonally opposite to it. The function is the reciprocal of the function diagonally opposite to it. For instance, we have sine theta. It is equal to 1 over cosecant theta. And this is the same for cosecant theta. Cosecant theta is equal to 1 over sine theta. We can see the same for cosine theta and secant theta, as well as tangent theta and cotangent theta. Product identity. Select any function on the hexagon. When you multiply the two functions adjacent to it, it will result to the function you selected. Okay. For example, we have the function secant. As we can observe, its adjacent functions are tangent theta and cosecant theta. Multiplying these two gives you secant theta. You can obtain 5 more identities from this one. Lastly, we have the quotient identity. Select any function and in a clockwise manner, take note of the next two functions from it. The first function divided by the second function is equal to your selected function. When clockwise manner, for example, we have tangent theta. Okay, the first function is sine theta, and the second function is cosine theta. Sine theta divided by cosine theta, as we know it, is tangent theta. This can be observed with the other 5 quotients, and you can find them by simply counting. For example, sine theta will give you cosine theta divided by cotangent theta, and cosine theta is cotangent theta divided by cosecant theta, and all. And now for the modular assessment, we are to prove or disprove these identities. Each correct answer merits 7 points, and partial points may be given depending on the solutions. These are the identities. And now, here's part 2. You will identify what behavior of periodic function is this one, then solve this problem, and that's it for the presentation. I hope you learned something from this discussion. Thank you, everyone.